In this video, I want to introduce parametrics or parametric equations or parametric representation. So the idea behind them and the idea behind algebra is it's all about relationships. So we're used to seeing algebraic relationships, something like y equals 2x squared plus 3, for example. So this equation is describing the relationship between x and y. And this is the sort of normal way that we're used to seeing equations with x's and y's in them. But the way we write this tends to imply that the value of y is dependent on the value of x. So we'll plug an x value in and that'll tell us what y is. But sometimes it's not the fact that y is changing because of the way that x is changing. Sometimes there's another variable, another factor. So a third variable in there, and x and y both happen to be changing because of the influence of that third variable. So often we'll call that third variable t, and it's called the parameter. So instead of writing an equation with y in terms of x, we could write two equations, so a set of equations. We could write x in terms of t, our parameter, and y in terms of t as well. And they're two different ways of writing it that represent the same curve or the same function. So for example, if we had y equals x minus 1 squared, this is what's called Cartesian form, and this is what we're used to. We could write this in parametric form as x equals 1 plus t and y equals t squared. So this is parametric. But both of these represent the same equation. And to prove that to you, we can rearrange these guys, these parametric equations, and we'll end up getting this. So if we were to solve these two simultaneously, or start solving them simultaneously, we'll call them equations 1 and 2. We'd say from equation 1, we can rearrange it to t equals x minus 1. Now if we sub that into 2, so we're going to have y equals x minus 1 squared, which is exactly what we had when we wrote it in Cartesian form. So both of these things mean the same thing, they're just different ways of writing it. Let's have a look at some questions involving parametric equations. So this one is another one similar to what we just did. We want to find the Cartesian equation of the curve whose parametric equations are x equals 3t plus 1 and y equals 2t minus 3. So let's start off again, let's call them equations 1 and 2 and let's rearrange one of them. Because they're both linear functions, they don't have any squares in them, it's not going to really matter which one we do. So I'm just going to start with equation 1. So from equation 1, I'm going to rearrange that to make t the subject. So I could rearrange it to have 3t equals x minus 1 if I subtract 1 from both sides. And then I'd end up with t equals x minus 1 all over 3. Now if I sub that into equation 2, I'm going to have y equals 2 outside of x minus 1 over 3 minus 3. Now that's not looking very nice at the moment. It is a Cartesian equation already, but I'm just going to rearrange it to make it look a little bit neater. So I'm going to multiply everything by 3. So I'm going to have 3y equals 2 outside of x minus 1 minus 9 to get rid of my fraction. If I expand out my bracket, 3y equals 2x minus 2 minus 9. Now I'm going to simplify this to a minus 11, and I'm also going to bring my 3y over the same side of the equation. So I'm going to have 0 equals 2x minus 3y minus 11. So again, these parametric equations and this Cartesian equation represent the same thing, just two different ways of writing it. For our second example, we're asked to sketch the curve represented by the parametric equations x equals t minus 2 and y equals t squared. Now one way that you could do this is to translate those into a Cartesian equation, similar to what we just did. And then you could either recognize what that curve's going to look like, or if you didn't, you could draw up a table of values. What we're going to do instead, though, is we're going to draw up a table of values for different values of t. So I'm going to start with t equals minus 3, t equals minus 2, minus 1, 0, 1, 2, and 3. That's going to give us quite a few so we can really get an idea of what the curve's going to look like, but we might not need all of them. And for those values of t, I'm going to find my values of x and y. All right, so when t is minus 3, x would be minus 3 minus 2, so we'd get minus 5. And y would be minus 3 squared, which would be 9. When t is minus 2, I'd have minus 2 minus 2, so minus 4 for x. And minus 2 squared would be 4. For t is minus 1, I'd have minus 1 minus 2, so minus 3 for x. and 1 for y, and we can keep going and substituting all of those in. So for 0, I'd have -2 for x, and 0 for y. For 1, I'd have -1 and 1. For 2, I'd have 0 and 4, and for 3, I'd have 1 and 9. Now what we have here is a set of equations, so we can completely ignore this first column now. So our first coordinate of a point that lies on our curve is -5, 9. So we'll draw up a set of axes. Again, you should always be using a ruler for these because I really can't draw on this thing straight. So use a ruler, try and get this as accurate as you can when you're plotting points. So if we're saying down here, that's -1, -2, -3, -4, -5, because our coordinate is -5, 9. So we'll go -5 up to 9. So we'll put that up there. Then our next coordinate is -4, 4. So -4 would be here, and 4 would be a little bit under halfway there. So let's put it here. Then our next coordinate is -3, 1. That would be about here. -2, 0. -1, 1. So it's coming back up. 0, 4. So that would be about up there. And then 1, 9. So back up here again. So if we draw our curve in, again, yours should be a much more accurate and neat sketch on your piece of paper than mine is. But that is the curve represented by these parametric equations. Again, we could have rearranged it into a Cartesian equation, and you might have recognized that it was a parabola with vertex -2, 0, and you could have found the y-intercept to be 4, and that's an okay way to do it as well, but it's just a different way, and it's probably actually a bit of a shorter method as well. All right, so that's an introduction to parametric equations.